Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to discuss flood hazard and risk mapping. So last time we understood the concept of urban flooding. We discussed what are the causes, primarily due to rapid urbanization. The paved areas are increasing and water holding capacity of the soil is diminishing, so that is why it is causing more volume generation, and that is a primary cause of urban flooding. Apart from that, mismanagement of stormwater drains and their lack of proper treatment by dumping solid waste, that exacerbates the situation. We also explored various methods to develop IDF curves. The principal method is where we are using by fitting a probability distribution, and then we derive the IDF curve. For that particularly we require finer temporal resolution data like hourly or sub-hourly, that is more useful. So IDF curve will give us for a given duration and given return period, that is frequency, what is the intensity of rainfall, and that is used to for stormwater network design. We can put that particular intensity in a rational formula, that is Q equal to CIA, to get the volume of runoff. We also examine the impacts and consequences of cyclones and tropical storms and how their occurrence varies from region to region in India. Today we'll understand the concepts of flood hazard, exposure and vulnerability, and how they are combined to determine the overall flood risk. We'll also learn the methodology of flood risk assessment by integrating the hydrological, hydraulic and geospatial data, and we'll explore the role of remote sensing and GIS in flood hazard mapping and risk analysis. So to start with, we present the flood scenario in India. So this is the annual flood statistics from 1953 till 2020. So this information is collected from Central Water Commission. So we can see that on the left x-axis the area affected by flood, that is in bars, and on the right y-axis we have the population affected by flood, that is in million, that is affected by the line chart. So you can see that very clearly we can identify years where this flood has been very devastating. This is 1, this is 2, 3, 4. So these are particular years where the flood effects have been very devastating. Now there might be a contradiction where you can see the area is less but the population is more, but that is due to the density. It is affected more denser regions, that is why this contrast is being seen. Next we also we can deduce that the fact is that around 49.8 million hectares of land is prone to flooding in India, and on an average each year 7.23 million hectare of land is affected by flood. Since 1953, average number of humans and cattle lost are 1,690,000 per annum. So that is a very alarming figure. Also around 4 million hectare land of cultivated land is affected by floods, and financially close to 2,000 crores of losses we face every year due to floods. So it is very imperative to perform flood hazard mapping and derive flood risks for different regions. So flood risk is a combination of probability of a catastrophic flood event and its potential consequences. So majorly it is quantified as a function of flood hazard, exposure and vulnerability. Now it is important to know that flood risks are not inherent characteristics of the natural system but human or societal concerns, because when people come into contact, so they become more vulnerable, and that is where the risk creeps in. So flood risk is hazard into exposure into vulnerability, and that is why. So it is one of the widely accepted non-structural measure which can be used to find the hotspots of floods. So flood hazard will specify the probability of occurrence of event in a specific region, and that is in space and time, whereas vulnerability would give an idea about the consequences related to either physical, social, economic or environmental terms. So just reiterating, hazard, that is a potential event that can cause loss of life, injury, property damage or environmental degradation, while exposure, These are the elements like people, property, infrastructure or system which are located in the hazard prone areas and which are at risk of being affected. So a large population which lives in the coastal area or coastal city is exposed to cyclone, whereas a remote mountain village has a low exposure to cyclone. It can be exposed to some other hazard, but when we are talking about cyclone, it can be less exposed. Vulnerability, that is a susceptibility of individuals, communities or system to the damaging effect. Like if there are poorly constructed buildings, so in case of cyclones they will get easily carried away by the winds. Now in flood there is a mechanism where flood warnings will indicate different levels of risk. So how they are related? So this is a normal level of water in a river where it flows during most parts of the year. Now due to one or other reasons, if the water level rises, now we see the pattern of rising, so then an alert is generated where your water level is significantly above the normal level, so there is an alert that be alert and watch out for flood. Now if the water level further rises, it touches a predefined level. So for each river cross section at the gauging site, these levels are well defined. Then the warning goes that be ready for flood and be ready to face flood and for evacuation plan as well. And if the water passes the warning level, it reaches a danger level where there is inundation happening and the river has already overflown and evacuation has to be initiated and all relief and rescue procedures has to be put in place. So this is how the warning levels are designed in case of a river. So when we do flood hazard mapping, it is a very vital component for flood proofing the areas. So if you know area is prone to flood, then how you can either tackle that particular thing by providing some preventive solutions, or in case of evacuation needed, what strategy has to be formulated. So when you do this mapping, you can create charts which are easily read, which are easily accessible, and that can a non-technical person can also identify, so that they can prioritize the mitigation and response efforts. Also they are to increase awareness. If people are staying in flood prone zones or landslide prone zones, so they can be given awareness that in case of an extreme rainfall event they should move to safer places. So this is how a flood hazard map looks like. So this is a flood hazard map for coastal urban floodplain of Surat city. So it is taken from a study by Jipkate et al. So you can see that for different return periods, by this time you already know what is return period recurrence interval. So the more the return period, the more discharge magnitude will be there. Of course the probability will be very less. So you can see that the red area, the river is flowing and then it is gradually spreading. So as you can see, the light red, the more the levels of hazards are ranging from blue and then it is going till red. So wherever you see high and very high hazards, so the entire map will be painted in red, and that indicates that there is a significant flood hazard corresponding to a given return period. So if you are planning any important, let us say if somebody wants to plan a nuclear power plant, then they will avoid those areas. They will go for preferably safe areas like this, where the hazard is very less. So when we want to identify hazard, we have to identify, analyze and evaluate all potential occurrences. Now here we are talking about flood, but it can be multi-hazard. Some areas can be prone to floods, cyclones or any other let us landslides. So in that case multi-hazard assessment is required. So here we show a district level flood risk map of India, where you can see that it is taken from this particular study, where for each district what is the severity and likelihood of the flood events that has been designed. So you can see that in particular Assam, many districts are in very high flood risk area. Then some districts in Gujarat, in West Bengal, somewhere in Bihar, somewhere in Uttarakhand. So they are among the very high flood risk zone. There are districts where the flood risk is very minimal, that is also being noted here. We can generate flood inundation maps as well to get a know-how of the spatial extent. So here is one such flood inundation map which is released by SDMA Maharashtra. So you can see all red indicates flood inundation. So these regions are very prone to flood. So if you want to do some policy measures, then you should, now here flood is for all categories of flood. It can be urban flood, coastal flood, riverine flood. They have considered all these categories of floods. Next is exposure assessment. So the presence of people, livelihood, services, resources, infrastructure. So these settings can be adversely affected in case of a flood event. So three indicators are chosen to just characterize a flood exposure. First is the population, second is the land use type, third is the critical infrastructure density. So here we can see that if the population is high, that increases the flood exposure. That means more number of people will be affected. Coming to the land use, if it is morely in agriculture or forest area, you would see that the exposure is less because less people are dwelling it. But if it is an urban area or a semi-urban area, so there you can see that more people are exposed to it, and the value of the land is again associated that way. Critical infrastructure, that means your hospitals, schools, office buildings, government buildings, so they come under critical infrastructure. So how much critical infrastructure per land area is present, that is where we can estimate the flood exposure. Vulnerability, it will evaluate the community's susceptibility to flood impacts by analyzing physical factors like what is the elevation, what is the rainfall, social factors like population density, infrastructure, economic factors like what is the economic importance of that area, if there are some industrial zones present or not. So these all things. So in a GIS setup you can collate all this information and then you can generate the vulnerability maps as well. So vulnerability will measure the level of proneness of a particular area, infrastructure or ecosystem to flooding. So when we take a GIS based approach, we quantify what are the exposure parameters, that elevation, slope, total wetness index, then flood depth, distance from river, then sensitivity is average population, average income, population density, if poverty index, land use, and then adaptive capacity, what are the food markets, what is the vegetation present in nearby, what are the transportation facility, road network, etc. that comes into picture. Finally, we'll estimate the flood risk. So it will assess the likelihood and severity of a flood event by combining hazard, exposure and vulnerability, all these three parameters into one. So it is very crucial because in many flood insurance studies they will charge the premium. If you are in high flood risk zone, your premium would be high. If you are in low flood risk zone, the premium will be low. In India the concept is evolving, but if you go to Western countries, flood risk is a very, flood insurance is a very popular term there. So let us discuss the flood risk assessment framework. So it is a proactive process of assessing the potential flood hazards and vulnerabilities to develop strategies that can reduce the damage and improve the resilience of the community. So the main focus in flood risk assessment is prevention, protection and preparedness. So 3 P's. So we know that prevention is better than cure. So we should be preventive rather than going for more efforts post the disaster. So in that we can develop early warning system, we can have real time setup where we can get all this data, then we can couple it with some hydrodynamic model, then we can generate forecast so that people can be evacuated earlier. What is the importance that if we have a FRA in place, we can plan and design flood control structures like dam, reservoirs, diversion and embankments. We can improve the land use planning by giving proper flood zoning. So in the zones which are very prone to floods, we'll avoid important infrastructure there. We can develop early warning system and we can create tailor-made disaster management plans so that emergency actions can be in place. Methodology for FRA: you delineate the flood prone areas, that is very preliminary task. Then you develop flood hazard maps. So it should show different intensity depending upon the depth and velocity of floods, or there's a particular flood scenarios which you can consider based on the return periods as well. So here hydraulic and hydrologic modeling will come into picture. Then you can perform a vulnerability and exposure analysis, where you can assess the social, economic and environmental factors that make the area more susceptible, and combining all this information you can at the end generate flood hazard maps. And lastly, based on this map you can create integrated flood management plans, where you are developing proactive strategies, where in case of such unseen event happens, how would you mitigate the vulnerability and manage the consequences. So these are the steps which we will discuss: data collection, hazard analysis, exposure and vulnerability analysis, risk estimation and risk communication. Be mindful that if an area is prone to multiple hazards, then you have to calculate the risk accordingly for multiple hazards. What are the practical approaches? Remote sensing and GIS is one of the technology which can be used. In the earlier lectures we have seen how geospatial data can come to a rescue. So drones can be used, in case of post disasters, but pre-disaster remote sensing and GIS information can be very helpful. Then you can have hydrologic and hydraulic models which can be simulating the real-time data, and they can give an information about what is the inundation depth in that particular area. Then some probabilistic approaches can also be employed. And lastly, if you have so many parameters, then you can perform some multi-criteria analysis to get a more robust and accurate view. Coming to the data requirements, we have classified into several categories. The first is the hydrological data, where you will collect rainfall from India Meteorological Department. Then you can collect river discharge from India WRIS, and groundwater. However, groundwater is not a very vital part, but in case where the groundwater levels are very high, so there what will happen when you are trying to model it, there at soil gets saturated very easily, so that information will come into picture that way. Then topographic data, you get digital elevation models, that is Carto-DEM is one of the source, SRTM is another source for digital elevation model. Then you get land use land cover map, that is from ESRI, again from NRSC also you can get LULC maps, and that can be blended in the model. Then population data you can get from Census of India, you can get from World Pop, and other infrastructure related data also you can get it. And if you want to see the historical flood magnitude and frequency, so Dartmouth Flood Observatory you can get. Also there is one India flood inventory, so that also can provide you this valuable information. Coming to the flood risk mapping, so here we have again referred to the same study which we discussed earlier. So you can see for different return periods the flood risk mapping is given. So on this scale we have the hazard, and this scale we have the vulnerability. So combination of that, so you can see the color scheme starting from no hazard, no vulnerability to high hazard, high vulnerability. So as you go in the diagonal axis, so the hazard and vulnerability both increases. So this matrix can be interpreted this way. So we can see the regions very close to your river flood plain. So these regions are more susceptible to your floods. Even at lower return periods also you can see the flood risk is much higher, and as you go away the flood risk tends to reduce. So remote sensing and GIS can be used in flood risk mapping. So this is an image from our analysis from the recent Punjab floods. So you can see that this is the permanent, how the flood has progressed on July 30, August 27, September 4. So how the water has progressed. So you can see that September 4 your inundation area is too big, and that has caused widespread damage in Punjab. So these floods were too devastating, and the post flood after flood effects also, many days power was cut and there was a lot of outrage as well. We can use the satellite imageries for flood analysis to get data. So Landsat can give you the flood mapping. So whatever area is inundated, that you can get it from Landsat, or you can get it from Sentinel-2. Sentinel-2 is at much finer resolution of 10 meter. Also the frequency is much faster, 5 days the revisit time. So for pre and post flood you can get what is the land situation there. Also Sentinel-1 will give you data which is because it uses SAR data, so you will get the information which can penetrate through cloud, so it is very perfect for mapping flood water. So you can see this one particular satellite imagery where we demonstrate the flash flood that happened in Uttarakhand, that is Dharali village. So you can see in pre-flood image the river is flowing very nicely, but during floods the river brought lot of debris along with it, and the entire village that got submerged, and you cannot find any trace of that particular village because of this particular devastating flood. So from NRSE these images are giving a very clear perspective of the devastation caused by the floods. There are some open source data. So flood hazard maps, NDMA releases such maps. There are flood forecasts by GLOFAS, then floodplain mapping by GFP Plane, and then flood event by India Flood Inventory, which I was just talking. So there you can get geospatial data for comprehensive flood research. You can use Google Earth Engine also to map the floods. So you can see that this is a pre-flood image, then you have the post-flood image. You can just superimpose to get the difference between that. So you can use any satellite imagery to get this kind of input, and you can get how much area is inundated using that particular analysis. We can use hydrologic and hydraulic modeling, so to accurately simulate the depth, because the satellite imagery will give you only the aerial extent, but you will not get the depth. So you can use any hydrologic or hydraulic model. So you can see the various depths ranging from 0 to 13 meter are shown here, and you can get an idea that what is the severity of that particular flood. So here we have compiled some flood models ranging from open source models to which are non-commercial, and there are some commercial software. So open source we have SWMM, you have Telemac, you have SWAT, then QGIS is an open source plugin, which are non-commercial and freeware data. So there you have HECRES, HECHMS, Mike, you can get a student license of course, but again Mike comes under a commercial category. Then like Mike Flood, 2Flow is again a commercial, then you have WMS and so on. So these are the list of softwares which can help you if you are pursuing hydraulic modeling. So some of them we will discuss, like 2Flow, it is renowned for its robustness, flexibility and high performance engine, particularly to model complex and urban environments. While Mike, it is a very comprehensive suite covering all aspects of water cycle from rivers to coast to urban drainage. So it is a very comprehensive package. HECRES on the other hand, it is the advantage is that it is freely available. So it can do hydraulic modeling, hydrologic modeling, then how water flows through natural and man-made canals, so that we can see. And Telemac, again it can be used to model rivers, estuaries and coastal areas. So you can see that how the model outputs are presented here. Lastly, we can perform a multi-criteria analysis where since there are complex factors involved, so decision making is sometimes challenging. So you have to give weightages to certain factors, and you have to come up with the what we can say, you can come up with some numbers where the weightage can be easily provided. So you can integrate various thematic information like slope, rainfall, LULC, distance from rivers, etc., and assign importance to them, and so that which factors are really contributing to flood risk, and that way you can cover both qualitative as well as quantitative factors. Otherwise in models you can only get the quantitative factors, not the qualitative. What are the challenges in FRA? That is, there are data scarcity issues. Of course, quality of the data is also a concern. Climate change and changing land use make historical data, that is an unreliable predictor for future floods. Also the very important thing is we lack high quality and high resolution data, which can lead to uncertainty in our model outputs. there are complex and uncertain models in which are, where we are struggling to integrate all information, like what are the flood types or infrastructure present, and sometimes we cannot quantify the social and human behavior in these models. So that is why this adds to a layer of uncertainty in our flood risk assessment. What can be the policy implications? We can come up with land use zoning regulations so that new construction in high risk floodplains that can be avoided. We can come up with insurance and financial mechanisms where risk based flood insurance programs can be developed. We can develop emergency management and preparedness plans where we can shape evacuation and early warning system can be in place, public can be made aware about such things. And lastly, to mitigate the adverse effects of climate change, our policies can focus on climate adaptation planning, where we develop resilience of our communities to overcome such kind of hazards. What are the key takeaway from this lecture? We understood that flood risk mapping integrates hazard, exposure, vulnerability to identify risk prone areas. Flood risk assessment supports for proactive flood management by linking data to models and spatial analysis. Remote sensing and GIS can help enhance accuracy of flood mapping, and we can also combine multi-criteria analysis to get a better inclusion of both the quantitative and qualitative factors. What is an activity suggestion for you? You can refer to the study by Saharia et al. On district level flood severity index for flood management in India and compile the information from that. So the open source data also they have provided. We will share the link of that in our coming slide. So you compile the information on number one, what is a flooded area? What is the number of flooding events that happened during the documented period, and the flood severity index for your district. So this information you can collate. So from where you can get this data? So you can get the data, I think it is provided on their website. So from there you can get this data. This is the additional reading material, the flood affected atlas by NRSC and the assessment of area due to floods by CWC. You can get the relevant information here. So thank you for your attention, and we conclude this lecture. In the next lecture we will discuss flood mitigation and nature based solutions. Thank you very much.